Hello everyone. Today I'm really excited to come over here and talk to you all about my thoughts on data protection for stateful applications. So the two important things, like whenever we say data applications and stateful applications, and combining them will have more ideas, more thoughts, and everything coming. So I'm just putting my thoughts over here. Uh, Okay, so this is just a brief about me. I'm Ashit Kumar. I'm working as the lead architect with Huawei Technologies. And apart from that, I'm a committer and PMC in Soda Foundation projects. Soda Foundation is nothing but a Linux Foundation project. And a little background is that before I started working with Huawei Technologies, I used to work with Veritas Technologies, which is one of the major known company in the storage area and all, and where I have worked on server and storage management projects and products, as well as some of the disaster recovery as a service product. One of the product that I worked and I'm really fond of is Veritas Resiliency Platform. And bit background about my education, I have done my master's from University of Pune, and also after that, what I love is I to impart my whatever knowledge I have. So I am a visiting faculty also over there, and some of the introduction, like you can get my some of the open source contributions from the GitHub, and of course you can visit my LinkedIn profile. So I have planned is that I'll keep this session a little very I'll give you some of the overview, what my thought about of the some of the basic concepts are, and then eventually we'll move on to some of the things that I really wanted to discuss about when we say data protection and stateful work applications. So what exactly is cloud native? First of all, like we have been hearing this cloud native. So cloud native is nothing but an approach to building and running applications that exploits the advantage of cloud computing delivery model. So this is very prominent in nowadays, like the cloud computing delivery model when we say. And why? Because it has got the distributed computing. The computers are distributed. It can scale horizontally, flexibility, from one cloud to another cloud. You can move your applications. That flexibility you get, resiliency you get. The resiliency in the sense you make your applications resilient enough, and as zero downtime, when we say, like, about some of the orchestrators like Kubernetes and all, they ensure that your application has zero downtime. And on the right side, if you can see that some of the benefits of cloud native, I've just tried to figure out. This is taken from the CNCF survey 2020. So if you see, this is a weighted average which has been showing that what are the benefits you get while using cloud native. And this is like something improved scalability, shorter deployment time, cloud portability, as we were talking about when we talked about flexibility and all. Uh, of course, cost saving and improved developer productivity. So your developer doesn't need to be more bothered about how my deployment and all. You create a solution and it can be scaled and ported anywhere. So these are basically the a very short cloud native. Of course, we can discuss much more thing, but this is a very short intro about the cloud native. And then the second thing that comes is the stateful applications. What exactly are the stateful applications? So stateful workload or application, when we say, is they save data to persistent disk storage. So that for the containerized world, you have a persistent disk storage where you can save the whatever the data you want. And data persistence. So basically, you save, you retrieve, and then start working, and then again save. So this is something like you can do. Some of the example of stateful applications are databases or a key value store. And basically, the containers uses the persistent volumes, so that they can store the data over there in a stateful application. I won't go in what exactly are the other aspect of the stateless applications. I'm just talking about the stateful applications. So stateful application has got say this cycle, what you want to achieve is that your app is running, you want to persist your data, you persist your data and back it up, And whenever you want your app, when it comes up in a different environment or in the same environment in the same cluster, you can simply bring it up. So that is what the purpose of a stateful application is, that you don't lose the state of your application. And stateful applications, as you know, that it has been growing like in a very fast way. So growing use of stateful applications in production. This is another CNCF survey 2020 that I have just put it. So if you see 55% of 55% use stateful applications in production, and this is for 2020. By this time in 2021, definitely this number might have reached somewhere around 60% for sure. So this is how the growth of stateful applications. So the survey was to do you run stateful application in containers, and you can see the result, right? But so evaluating is 12%, so 15%, and another evaluating is 12%. So you definitely know that this is going to increase, and this must have increased by now. Now we have talked about data protection, stateful applications, cloud native, and all. Now we'll talk about the data protection in cloud native. What exactly? So data protection, forget about the cloud native for a while. So if you see data protection, data protection is something like you protect your data, you can retrieve your data. So basically, for your application, you don't want to lose your data. So that is how you protect your data. So, and of course, now in today's world, no one wants to consider data protection as one of the consideration. It has become a necessity right now. If you don't protect your data, so whenever you are planning your application run or your data center management and all, right, you definitely bring into picture the data protection. Data protection is one of the most important or vital aspect that you consider, right? And so basically, why you need the data protection? You need it for uninterrupted application availability, and you want to recover from failure. Consider a situation that you have a finance application running, and there is a failure happening. So and if there is the data is not protected, definitely this is like the last and the worst thing that you will think of, right? And even if there is a failure, you don't want the downtime, you want to recover it fast. So anyways, failure you cannot avoid it. Sometime it becomes it may happen, and you don't want that. Okay, there is a failure, I cannot recover. That you don't want. So recover from failures is what. And definitely, the way the cloud native and the stateful applications that you're talking, the use and the acceptance of those are increasing. You definitely want to consider the data protection, and you don't want your production data to keep failing. You just want to recover it from it. And a stateful application and data protection go together. So stateful applications, whenever you are saying you want to protect the data, and there are some you want to maintain the persistence of the storage, the operational metadata, whatever the metadata that you have, you want to maintain that persistence. Continuing on the same data protection. So data protection, basically, if you see, it revolves around your backup and application backup end to end. When we consider about the cloud native world, it's like your container, suppose it is running some images, the metadata it has got, the persistent volumes it has got. So you want the application and its states to be backed up. So whatever state it was having, so you want to just back it up there. Definitely you want to minimize the RTO. So in a stateful application, the RTO should be near zero, and RPO based upon your strategy that you have thought of for backup and all that, you definitely want to minimize the RPO. In case of failure, we don't want to run around that, okay, what is the cause of the failure, or how we can bring it up. You just want to resume without delay. So that is what the goal for why we think of the data protection, and definitely the data protection for the stateful workload. We need to think about all these things, right? And there are definitive ways that even the orchestrators, the container orchestrators, and all that they provide. But again, definitely some of the things we need to think of. So what an ideal scenario for your data protection will be? You back up, you restore with all the pieces tied up together. So whatever the metadata, whatever the workload state was there, you just want to restore from there, and you basically you orchestrate all these things. So someone needs to orchestrate all this so that you don't have to run around the storage admin, server admin, and all. So someone can take the can from a single point or a single place can orchestrate everything. And basically, what do you need? You need two set of interfaces to discover the components, whatever the components your container or the cloud native. Say for example, in your Kubernetes environment, you are running some of the pods and all, right? So you want to discover those components. You need to manage the life cycle of them, like how you retrieve, how you back up, and everything, right? So basically, and apart from that, you need the infrastructure. As we said, that stateful application consists of your data as your persistent storage backed up and all, right? So you need some interface to take the snapshot. You need to have some object or file storage. So these interface you want to interact with. Uh, so whenever these things in infrastructure interface we think of, definitely the CSI and all will come into picture for any storage admin and all, if it is external storage that we are providing, right? So basically, we want to achieve what? Backup and restore, right? So backup helps in your application migration, application rollback to the last consistent state, application cloning, application retrieval, and a few things that we keep in mind to have an efficient backup, right? So backup is something like it's not like okay, I'll take a snapshot, I'll just keep it, I'll just dump whatever I have, I'll just dump it. You cannot do that. You cannot scale with that approach, right? Because there may be some deduplication that you need to do. You need to consider of the when you are taking the snapshot, differential and sequential snapshot, whatever like your snapshot strategy might be. Again, apart from all this, if you are running some of the applications, right? The applications are writing data. So there may be some of the data that are still in the cache, that the application has written and which has not been persisted actually on the storage. So there will be some discrepancy that you will see. So you don't want to, and also when you are backing up, you want to don't interrupt the application and all, right? So in any ways, you don't want to get into any sort of downtime and all. So you need to quiesce the data, quiesce your applications, right? Quiesce your application so that so when you are taking the backup is like from where you can retrieve it completely, from that point of time. So that needs, and restore depends, as we talked, like efficiency of the backup. So how efficiently, how frequently you are backing up. So snapshot and backup are two different things, as you know, right? So a snapshot I'm taking, for example, I'm taking an example like a snapshot I'm taking. Now this snapshot, whenever I am backing it up, how efficiently I am backing up. So is there any so there might be some considerations about the network bandwidth uses and all. So those things needs to be brought in. Then the accessibility of backup. So for example, I am in region say A, and I have backed up my data, and I want to retrieve it or restore it in region B. So now region B should have the accessibility of backup that we have taken, right? So those things needs to be considered. And also cloud native backup strategy defines near zero RPO and RTO. RPO, near zero RPO is again a subjective thing. RTO, usually you want to achieve like almost near zero RTO. So that is where the backup and restore. So till now we have talked about the data protection, how for the stateful application, the requirement, the why we need the application backup and restore, right? Now over here, I'll just try to bring in one point is that nowadays it's like uh, the strategy also. So in very olden days, we might have been hearing that, okay, so this is for example, if I talk from a storage background, is that say I'll say that this is a vendor X shop. So all the storage will be coming from that storage, or a vendor X cloud user, right? So whatever they use, they will be using it on cloud X only, from the cloud X only. They will be getting the compute storage or anything from the cloud X. Now it's like multi-cloud, the hybrid, everything is like very like, it's not say that something that we want to achieve, but majorly it is considered while you're planning, right? So suppose I want, so basically I will talk about the data protection in alternate environment. What alternate environment means is that uh, first of all, anyways, before alternate environment, applications should be protected and available. Now, when requires storage availability in heterogeneous environment. So this is something like a very important thing, like heterogeneous environment. When I say is that, say I snapshot based backup of on-premise app and restore it in cloud. So I have an application which is getting backed up on-premise or running in on-premise, and I'm backing it up. But when I want to restore, I want to restore it in a cloud. Or say, suppose I am backing it up, and for some reason, like say for a temporary application analytics and all, I want to retrieve that, and those analytics I want to do it in cloud. Now whatever the backed up data was, that I want to use it and use it in cloud. So my compute will come up, that will use this storage, this state and all, right? And from there I will do some analytics and just switch it off. So that is one of the consideration, but usually you want to have like your backup done over here in on-premise, and you want to retrieve it in, or your container which is running, or your application which is running in your on-premise wants to come up in the cloud. So those things are like, or your alternate environment. Your environment is not the same. So basically, and how you achieve it, that you don't require storage vendor support. Is it? No. So suppose storage vendor support is definitive if you are using an external storage. So that is one. Apart from that, okay, when I say that storage vendor support is necessary, there are some solutions which can be used. Like, can I back up my cloud A application and restore in cloud B? When I say it can be done using the cloud volumes or a file system level backup. I'll talk about more about this file system level backup. Basically, the cloud volumes, most of us like know about that. Okay, all fine, all good. So why I am here? See, when we talk about this data protection solution, there will be several enterprise solutions, several solutions, proprietary solutions will be there, which will be there to achieve this. But actually, sometime it is like how we can do it in open source way, so that we get more of the contributors, more of the use cases getting covered and all. There are solutions like Velero is one, Restic, we'll talk about Restic is one, Longhorn from Rancher is there, and also we from the Soda team are doing some of this. We have started this initiative for the data protection for stateful workloads. So that I'll talk about. Okay, so just a very quick introduction about Soda. You can definitely go to the sodafoundation.io page or the GitHub page and you can find it out. So Soda Foundation is an open source project under Linux Foundation that aims to foster an ecosystem of open source data management. So it is basically for the data management in open source and storage software for data autonomy. Soda Foundation offers a neutral forum for cross-project collaboration and integrations and provides end users quality end-to-end solutions. So in Soda Foundation, if you go to the page, there are different solutions for multi-cloud, different solutions for containers, for Kubernetes, for storage resource management, analytics, orchestration, and all. And definitely, like some of the storage projects for storage provisioning and all, we have been getting contributions from different companies. Different companies are putting their projects as ecosystem project and the Soda Foundation. So you can get more idea about Soda Foundation projects over there. And Okay, so what the Soda Foundation is actually doing for stateful application, for protection of stateful application. So very recently we started on something like how we can protect our applications in a heterogeneous environment. Say, for example, I'm running my applications, my containerized solutions. See, in a like my this is my managed Kubernetes environment where I'm managing some of the applications in cloud A, and I just want to like move my application to cloud B, or if I just want to make it my failover strategy, that if cloud A fails, then I'll bring it up in cloud B. So how I can achieve that? So okay, so just to give, because I have not talked about the projects, let me talk about slightly about the project. So on the right side, you see this little yellow box, which has got Soda Hotpot. So Hotpot is something like Hotpot of three projects, which is under Soda Foundation: API, controller, and doc. So basically, API is the API interface for any storage management or data management in a heterogeneous environment. So this is basically a northbound facing project. And we in between we have a metadata management or a bookkeeping sort of project, which is controller. It runs the etcd, and on the south side we have doc, which is a doc for different storage plugins that is there. And also we have a Soda MVP project, that is a northbound plugin project. Right now it serves multiple projects for the like multiple use cases for VMware and all. But one of the major use cases is that it provides you uh, like a layer above the different CSI vendors, where you can connect to that, and it can connect to any of the CSI. So you see on the left top, it is any CSI driver which supports local PV. So just forget about this local PV. That supports any CSI driver. Okay, and this is running on a Kubernetes node. Okay, so this I'm talking, okay, we are coming to the Kubernetes aspect, but yeah, we are trying to make it more generic for any orchestrator. Underlying it can be a container only. So if you see, this is just a flow example where from a Kubernetes application, you get a requirement for PV. So there is a Soda CSI provisioner, which is listening to these requests. So what it will do is that it will go and connect to a component called Soda proxy, and Soda proxy and Hotpot will have the configuration, some of the custom properties. So as a Soda profile, you can set those custom properties. On the down bottom, you can see the JSON about that. We'll come to the Restic repository and Restic password thing. So that will come, but you need to specify some of the cloud components about that. Okay, so now this will go and connect to the Soda doc and all, and basically the hotpot is the provisioner, right? So this Soda CSI provisioner then will connect to the third-party plugin, the vendor plugin, and then it will connect to the Soda syncer. Now this Soda syncer, so other components are the existing thing. So whatever 1, 2, 3, and till 4 you see, they are existing components. Now we have written a Soda syncer, which uses Restic. Restic is an open source solution for file system level backup. So I have given you the link, so we can go and check over there. So it will connect to the Restic. Soda syncer is like right now it is using Restic, but it can be. We are trying to make it like more generic. So basically, any type of this backup solution we plugged in. So over here, Restic is getting used, and Restic basically needs some of the like cloud providers. That's why it creates a repository. So you need to give that. What exactly is the directory, or you can give a root directory also. So it is a file system level backup, right? So you need to give that repository. You create a repository. You need, and Restic, as you know, that it encrypts all the like data and all. So you need to provide the Restic password because it will be encrypted. And when you're using it or downloading, it needs to be decrypted at that time. So you need to give that password. And Restic repository you need to provide. Right now, the repository is object store in AWS that we have given, S3 object store. And Restic is basically compatible and works with all these different cloud providers, AWS, Google, OpenStack, Swift, and all. So this 6th point is that where Restic comes into picture, and it keeps backing up your. It takes you can give time interval when it takes a snapshot of the file systems and back it up in your object storage, and from the object store you can get it anywhere. And if you have, say for example, say I have backed up in my AWS environment and I want to retrieve it in my Google TCP environment. So what you can do is that you can simply download it as a file system, and those file systems can be transferred, or if there is a connectivity, it can be connected to the Google environment. So that is where the file system level backup comes into picture. I'll just go little deep into the flow, like how the protection using Restic works. Is that your application, first of all, your application will have a storage request that will come to your Kubernetes API, then it will go to the SODA provisioner, and we saw that SODA CSI provisioner. Then that request will be dispatched to the SODA CSI. So this SODA CSI is our SODA MVP CSI plug and play. So any CSI can be plugged and it can be used. And this will be then routed to the vendor CSI plugin, and that vendor CSI plugin will connect to the hardware or a STS. I have written a STS. Hardware can be like your any storage vendor, and SDS I have written like you can have your own Ceph or LVM based solutions where it can connect. And then it says that, okay, I am done. I have provisioned the storage. Once it has provisioned the storage, what it does is that this SODA syncer, if you see the fourth box, the SODA syncer collects all, so it invokes a API, connects to the Kubernetes API and gets the application objects, and it uploads it into the S3 storage. It sends it to the Restic, which eventually stores it into the S3 storage. And also, so these are the objects, whatever Kubernetes objects are there, it collects that, and after that, it starts creating the snapshot backup. So it will check the mount points. So basically, it will read the mount point, and that mount point, wherever the storage had been, the provisioned storage has been mounted, the file system mount has been done. So it will keep reading those mounts and take a snapshot and upload it to the S3 storage. And then after that, it will just return it back to whatever it has been done. And same thing you can do like for the restoring. Restoring, we need to just download it from the S3 storage and start using it. So it is simply file system. So your application, that is your planning, like how you manage your file system path and all, right? So that is a different thing. So that is for the applications. Now there is another approach. We talked about the Restic, that is a file system backup. You remember when we talked about like it can be a simple block level snapshots also. That is definitely support from the hardware. So what it does is that the first the above layer of the flow is seen. That storage request will come, it will go to the storage provisioner, it will route it to the SODA CSI. SODA CSI will talk to the vendor CSI or the TP, and then it will connect to the hardware. And the application, so basically the provisioning will happen, provisioning of storage will happen. And after that, it will keep collecting all the objects, application objects. And when I say application objects, it is not about the file system or the other, because we are already taking, we are already provisioned the storage, and this is just the metadata or the application. So say for example, I have some pod YAMLs and all, like stateful set, daemon set that I have created. Those things will be getting backed up. And this SODA syncer, this will work simply as the it will talk to the vendor CSI for if they have the capability of taking the snapshot, block snapshots and all. So it will talk to the SODA CSI and say that, okay, whatever the storage had been provisioned, just start creating a snapshot. Now this snapshot schedule and all, you can configure it. And they will take the snapshot and take the hardware snapshot. And those snapshots right now are with the hardware. So they will, and again, for the restore, that can be restored from the snapshots. Now, if you see over here, there's three storages just used for the application object. Previously, in the Restic case, it was basically the Restic used it for the file system based snapshot only also. And over here, the snapshots or the pure vendor storage CSI snapshots you can see that we create. So these are the two different solutions we are talking. And okay, again, I'll just come back is that we have been talking about this. Okay, sorry. So we have been talking about this. Basically, as I said, there can be proprietary solutions, there can be vendor solutions, and all enterprise solutions can be available. But this is completely an open source thing that we are trying, and we are trying to leverage some of the open source solutions as well as the CSI features and all. So those things we are trying to combine. We are trying to create a solution which will be basically used for the data protection for your stateful workloads. And as it is open source, it gives more opportunity for bringing up your use cases, trying to integrate it. If suppose I'm an user, I have a different set of use cases, which is like a slightly addition or some that can be built upon this solution. I can go and contribute to this project and start solving the use cases. So that is where the data protection in stateful workloads comes into picture. And as you know, we talked about this stateful and data protection. This is go really hand in hand. So we need to. So that's the open source we I have talked about how we can do it. Okay, so I have taken some of the references from the GitHub Soda Foundation. You can check. Also, Restic.net. You can check that what exactly do, what are the support metrics, capability. In fact, like Restic or the Soda Foundation solutions may have some of the restrictions. We can talk about that as a community. We can discuss about this, and we can try to make it more solid, both about the Restic as well as the Soda Foundation. So I talked about the Soda Foundation. You can join us. You can go to the GitHub, check our projects and all. Definitely, I'll suggest you to check the Soda Foundation MVP project as well as the examples project where we have been trying to bring this type of solutions, the innovative solutions. You can follow us on Twitter. You can join us on Slack, and definitely you can mail us anytime at info@sodafoundation.io. So that's pretty much all about the data protection for stateful workloads. I know that this is a very short discussion that I have because this is a very important and definitely there will be different thoughts, different perspectives that will be coming into picture. This is not that we can cover in a so short time. So please reach out to me. You can ping me on Slack channel. I'll be available, and then we can discuss. If you have some suggestions, if you want to contribute, you are welcome. And even you find it something like we can add some of the use cases, please start suggesting over there. Thank you, everyone. I hope this was something good technical things that we have discussed, and we'll keep discussing about this. You can reach out to me, check my LinkedIn, and you can mail me at. You can basically reach out to me over Slack, and definitely will connect over there. Thank you, and thanks a lot for joining the session. Hope to connect. Thanks a lot. Bye-bye.